Hey everyone, so we've been studying these reactions of alkyl halides that they undergo either SN1, SN2, which are both substitution reactions, or E1 or E2 mechanisms, which are of course from elimination reactions. And we've already done a little bit of discussion about, well, when will something do SN1 mechanism versus the SN2 mechanism, or when will something do the E2 versus the E2 versus the E1 mechanism. But now I want to take a minute to talk about competition between all of them because they're all the same types of thing. In each case, there's an alkyl halide starting out reacting with some kind of nucleophile or base. And that's going to do one of these reaction mechanisms, or maybe even multiple. So how do you decide between them? And it can get really complicated. You've already seen some of the many factors. So it helps to put those into a neat little chart or a neat little graphical format. And I've got these two that I'll link to on the Canvas page right below this video, or maybe in the on YouTube, maybe in the comments or in the information section. All right, so here's the first one, and this one actually comes from your textbook author. So this is a summary of substitution versus elimination reactions of haloalkanes. So basically what he's saying here, and how you read this table, which is actually what everybody says, is you start out asking yourself about the alkyl halide that we're analyzing. What is that alkyl halide that we're analyzing? Is it a methyl, meaning is it just a carbon with a halogen directly attached to it, like this? Or like this is an example. Methyl is an example of that. Or is it primary, where you have a whole chain of carbons, but there's a halogen attached to it at the end? Or secondary, where you've got a chain of carbons coming in and a chain of carbons going out, but there's a halogen branching off of it? Or tertiary, where there's a chain of carbons going off in all directions, and there's a halogen coming off of it. So right away, it can sort of tell you what reactions you should consider. If you're up in this category, you should be thinking that it can't do an SN1 reaction, and it can't do E1 reactions either. Or sorry, this should be separated here, like this. That all you have to consider if you're looking at methyl is SN2 reactions. The only substitution reactions are observed. If it's primary, you don't have to consider SN1 or E1. You just have to consider SN2 or E2. And then it'll go on to tell you when it would be better to be going that direction, or when it would be better to be going this direction. The main reaction with strong bases such as hydroxide or ethoxide, also the main reaction with good nucleophiles or weak bases such as iodide or acetate. E2 is the main reaction with strong bulky bases such as potassium tert butoxide. So if you had a primary haloalkane and you were using a base like tert butoxide, you would pick E2. Or if you were using a base like these, you would pick that. And so on and so forth. Here's the secondary one. And it can actually, it's the worst one. You can do any of the reactions, and SN1 and E1 pretty much always happen together. So if you're doing one, you're doing the other. And this tells you a little bit how you could preferentially get that reaction or preferentially get this reaction. And then tertiary, it says don't worry about SN2, you can't do that, but here's how you might get E2, or here's how you might get the SN1, E1. So this is a great table. It's a pretty easy to use thing. You just have to start by analyzing the alkyl halide, which category are you in, and then it'll tell you what you might be getting, which mechanism might happen. All right, here's another one. This one came from a website called practicallyscience.com. There are a lot of versions out there. You may see it on other videos, but it's a good one. So basically it's got this axis, and it's a little bit more inclusive than that last one. Anything that puts you over in this category, which would be one of these things or these types of conditions, would give you SN1. Anything that puts you over in this category would give you E1, this category E2, SN2. So you can already see what's going on. So to compare, what they're showing you is the alkyl halide here. The substrate or alkyl halide that's getting attacked is right here. It's saying SN2 reactions happen when you've got these kind of alkyl halides. And this you can see as a secondary one. a secondary alkyl halide, or next to an aromatic ring, and we'll study that in future chapters. So sorry, I should point out that this is breaking down the complicated region of secondary, where you can compete and do everything. So it's really focusing on mostly secondary haloalkanes, where it gets really, really messy in this area. That's why I give you the two of them, is one gives you some very general information about what to think about, and one digs in a little deeper to the nitty-gritty of the complicated areas. So then it tells you that if you have these bases attacking, you're likely to be SN2. If you have these bases attacking, you're likely to be SN1. These bases attacking are likely to do E1, where these bases attacking are likely to be E2. These are the stronger versus weaker base versions. And that's what it's really telling you on this major axis, that basic conditions, stronger basic conditions, will give you SN2 or E2. Acidic conditions will give you SN1 or E1. And then you can differentiate between the two by going protic solvents, things with an H attached, or aprotic solvents, things without the proton that can be donated. You can differentiate between these two in basic conditions by bulky or sterically hindered bases, or small unhindered bases or nucleophiles. You can generally differentiate on this axis by going weak bases will prefer substitution, strong bases will prefer elimination. So you can see that in the examples they've given, where they've given you examples of stronger bases versus weaker bases, stronger bases versus weaker bases, in acidic conditions versus stronger bases versus weaker bases in basic conditions. That's basically it. They pretty much show you, and they also give you the example that will become relevant as we start to study things adjacent to aromatic rings in future chapters. It's a pretty nice sort of graphical way. You can be like, well, what are my conditions? Where do I go on the axis? And then am I stronger or weaker? And then does my thing actually match the examples that they're giving? Again, this is the secondary substrate, the molecule that has the alkane or the halogen on it, and these are the nucleophiles that are attacking, or the bases that are attacking. All right, so that's it. These will be posted near this video. Hope it helps out.